Welcome in the arena. My name's Allyson Klein, and today is a data insights episode, which means I'm here with Jeniece Wnorowski. Hey, Jeniece, how you doing?
Hi, Allison. I'm doing great. Happy Friday.
Happy Friday to you. I'm really excited about our episode and the folks that you brought with you today. Why don't you introduce them?
Yeah, we're bringing a whole party today. We have a couple of folks with us, but I'm really delighted to have Dan Brown with us from DigitalOcean, as well as a partner in crime, Ty MacAdam from Solidigm. So, welcome to the program, guys.
Thanks, Jeniece. Thanks, Alison.
Thank you very much.
Dan and Ty. Now, Ty, you've been on the program before. Dan, you've never been on. Why don't we just start with a brief introduction of how you're engaging in your respective company and how your teams are intersecting the broader topic of today, which is building and delivering data center infrastructure to AI-driven workloads.
Okay, so I'll go first, Ty. My name is Dan Brown. I manage the hardware engineering team here at DigitalOcean. We're responsible for all the server hardware here at DO. From ideation, we work with the product teams and the forward-looking folks on what hardware they want to build, all the way through retirement, where the servers lived out its useful life cycle in our fleet, and then gets retired and sent off to be recycled, and so on. We handle everything in between, including qualification, onboarding, release to production, firmware management, component qualifications, and sustaining engineering during the operation of the hardware in the fleet. So we've worked with Solidigm extensively. They've been one of our key vendors for storage in our hardware designs for a long time now, even before they were called Solidigm, if I can say that. And we rely on their expertise and breadth of product solutions to help us build next generation hardware for cloud and AI.
Amazing.
Wow. Yeah, that's a good introduction. I'm Ty MacAdam. I'm one of the account execs here at Solidigm. DigitalOcean's been a customer of mine for many years. Great customer, great partner, the way I look at it. And my job is to work with them, work with Dan and his team to really help make sure they're getting the right drives for the right solutions to help them grow and be successful. And it's really all about just communication, collaboration, and a set of close partnership.
Thanks, Ty. That's well said. So let me start off with Dan. Dan, when you kind of look across your customers, what are some of the most common challenges you're facing when trying to operationalize data for AI, and whether that's performance, overall cost, scalability, or is there something else?
Those are all concerns they're expressing. The biggest three factors are basically where and how their data sets are captured. So whether they're using it for training or inference, where their source data is located, where they're acquiring it from, how they're aggregating it, so on. Secondly is how quickly can they get that data from the source into their AI cluster, right? What's the aggregate bandwidths between their sources and wherever they're doing their processing. And then the third is how quickly they can exchange tokens between the systems in the AI cluster to reduce that data down into a meaningful data set that the AI system can use for inference against and so on. So on those first two topics, Solidigm's helped out with us, been a valued partner in helping us get high quality NVMe devices like PCIe Gen 5 bandwidth and so on that support our different technologies that consume them. Our DigitalOcean Spaces and our DigitalOcean Volumes products, for instance, which are our storage infrastructure that we use, our customers purchase. And then in our AI inferencing and training clusters, Solidigm is providing the high-speed NVMe on board on the local system for the training, GPU training systems to write their data down to and to read their data from as they're doing the actual the AI training, like model training and so on. And so having that high-speed NVMe close to those GPUs is very much critical to that operation. Having that data set be very close to the GPUs, having the minimal amount of time between the data could be read in, transformed, and read out, and so on. That's really the key thing. And so Solidigm provides that very high-performant, very reliable infrastructure for us, both on the local server and remote, to solve those first two items. On the third item, we build GPU fabrics that are very high speed and allow the GPUs to share their local storage, all those Solidigm devices across that GPU fabric, so that all of that high speed NVMe can use in one big pool to hold huge amounts of data for all those trillions of parameters that be loaded in those AI models and so on. So it's been really critical to have Solidigm as part of that conversation, have them be our partner in that path on building those high speed solutions with that very tight coupling of storage to AI processing to help solve those operational issues our customers experience.
You know, what you're saying is kind of fascinating. And one of the things that I was thinking about when you're talking about getting max GPU performance out of that cluster is the fact that these are very complex interrelated systems. And when you look at the interplay between compute storage and data pipelines, that can get really complex. Where do you see the tension today emerging as you're building out infrastructure?
So what we're seeing really is that the AI solution designs are limited by what we call data velocity. How quickly can you get your data in, transform it, and get it back out into the next useful step in the pipeline, right? So we see a lot of friction from customers who are coming in using older legacy storage solutions. A lot of folks are running on old JBODs or old storage arrays, even spinning disk HDDs and so on that have been around for a decade or more, and they're trying to use that storage infrastructure from which to source their AI data sets and move them into the cloud. And they're finding that creates a lot of friction. So when they move their data into the DigitalOcean environment, into our high performance block and object storage, or into our right directly onto the AI machines, they realize the benefit of having that local data close to the AI machines, and they're able to improve their velocity by leaps and bounds. So that's one of the biggest things, is to try to help the customers understand that in being limited by the infrastructure that you have can be a real limiting factor to the speed at which you can do your AI transformations and so on. So actually leveraging remote hosted infrastructure in DigitalOcean or even other third-party clouds is a way of sidestepping that limitation. But at DO, you're getting max velocity and max performance thanks to our high performant storage solutions, leveraging the Solidigm solutions.
Nice. So with that, Ty, you guys are working together across cloud infrastructure storage technologies. How do you view this collaboration, and how does it address some of those challenges differently than, say, if each layer were approached in isolation?
So my goal is to work with our customers to design together, not in isolation. A lot of the kind of challenges our customers face are latency, cost, security, scalability. These things don't live though in a single layer. They actually they span across all of them. So it's all really, why I mentioned earlier, is about collaboration and partnership and working really close together with my customers to help overcome those issues. We want to help them build a more balanced system with fewer bottlenecks. You can scale the infrastructure predictably and reliably, as much as possible. Really, helping them make smarter decisions on, overall end-to-end solutions, tiering, replication, resilience. These things get better when their storage and the infrastructure are actually working together and aware of each other. Again, like Dan was saying, faster problem solving. Integrated visibility it means where you can catch the issues earlier, and so you're not finding out that you've been trying to root cause something on that's 2 layers above where you actually should be looking. So trying to help things to be solved faster, be more efficient. So it's really like our customers' problems don't actually respect the boundary between infrastructure and storage, so our solutions shouldn't have to either.
Dan, I was really intrigued by what you said about data velocity, and that makes a lot of sense to me. When you think about how DigitalOcean differentiates in market, how do you think you're genuinely approaching this in a differentiated way that supports your customers' data-intensive AI workloads?
So one of the things recently you'll notice that the AI market has gotten very crowded. Lots of providers, lots of folks coming in, just startups out of nowhere, companies you've never heard of. Uh, Everybody switching things from things like Bitcoin mining or making shoes to hosting GPUs. So there's a hallmark to the what we call those neo clouds, right? That they're focused on one thing, which is just GPU hosting. They're taking GPUs and servers, shoving them in boxes, and then selling them by the hour to customers. We call it GPU landlord, right? So there's no improvement on top of the GPU hardware itself. You have to bring all of your own expertise, your own data scientists, your own hardware engineers, your own people to do that development on that server to make it actually useful to you in an AI environment. So at DigitalOcean, we have a whole suite of solutions that have been around for a long time now. We've been in the cloud business for over 10 years, and in the AI business for over 5. And so our infrastructure is designed to provide not just the GPU infrastructure itself, but the compute cloud that surrounds it. So any compute or storage that you need surrounding it, the volumes and spaces products that surround that AI infrastructure, exist specifically to make it a more robust product. They are there to be leveraged with high-speed interconnects on network from that AI cluster into storage, into compute, and so on. They're very proximate to that. You can get compute resources in the same data center as the AI, have them be on the same backbone network, and the same data center network, and so on, very tightly coupled. So that improves velocity. It's something that other providers aren't doing. Like unless you move up to hyperscaler realm where they're doing some of everything. But our designs are really meant to facilitate that AI solution to improve its velocity and so on, to help not only create high performance top of market solutions, but also budget compute resources. So when folks are at lower tier, right, they're trying to aim for a lower price inferencing product or something like that. We also offer products to meet those needs as well. We're not just aiming at top of market the way a lot of AI companies are today. We have a solution called DOKS, which is our Kubernetes solution, which lets you run containerized applications on DO directly as containers instead of as virtual machines. That then removes some of the like SRE requirements, the administration requirements of the OS. And then recently we announced our Inference Router product, which is actually allowing you to take a data set and have the router look at the data set and evaluate what it would cost based on the different models that are out there to run against it. And then you can say, do you want to run a top of line model on like a B300 Blackwell GPU, or maybe on an MI355X AMD GPU, or maybe you want to run a discounted one on like an H200, or maybe even a lower price on an H100, or let's get down to bargain basement of RTX 4000, RTX 6000 GPUs. These are all lower in the market. And you can look at the cost for what it would cost you to run that data set against that inferencing engine, and then choose to route to whichever one meets your price point demand, right? So all of this optimizes the way that these customers can use our AI capabilities, from serving them not only at the bare metal. We rent bare metal by the hour, we rent droplets by the hour. That is definitely our bread and butter business. But the inferencing router is opening up an entirely new layer of business, which is basically token as a service, where when you're running inferencing workloads, you can choose based on the required SLA you have for that workload and the amount you're willing to pay for it, which direction, which model, and which GPU you tune towards without any custom development on your side. You're not having to run H100s, B300s, all these other GPUs on your own to provide that resource. They're just available as a back end of that inferencing router. So what we say is not Neo Cloud, DO Cloud, because that's where we think the promise is, right? And that unified cloud infrastructure that has this smattering of resources that are all very pertinent to AI processing, and that enable cloud operators, AI operators, to have higher velocity, lower costs, visibility to cost impacts, and just all those good things that DO has in the past provided to its cloud tenants and cloud customers in general.
I love that.
Can I get a shirt that says that? Not Neo Cloud, DO Cloud. That's, I like that.
I'm trying to work on that with our marketing team. We'll see how far I get.
I'll wear one, Ty. But let's take it back for a sec, Ty, to the Solidigm side. I mean, how do you feel people should think about storage, not just as a capacity layer, but as something that actively impacts AI performance and efficiency?
Exactly. Storage used to be a passive layer where everybody just thought of it as where the data would sit. That doesn't hold up anymore. That's not how things are, especially with AI. It's now storage is the foundation of AI. Solidigm, we're an active part of the whole AI data pipeline. It's now about moving the data. So if your storage can't keep up, then your GPUs sit idle. And then, of course, that's a bad thing. So data throughput is a direct bottleneck on training performance. So you're only getting the compute that you're paying for, if the feed is fast enough. So for us, our focus and really, helping our customers to use the right drives to that deployment, it's about efficiency and economics. Solidigm's high density NAND or QLC is it means more data closer to the compute at lower power draw. And that changes the whole TCL math, and really significantly, because as your deployments scale, that's where it really matters. So we really try to educate our customers to think of it as, stop thinking of it as where the data sits. Storage isn't where the data sits. It's more about how fast intelligence moves. Because really, when it comes to AI, those are the same conversation.
Absolutely agree, Ty.
Now, from a DigitalOcean perspective, Dan, how do you think about simplifying that complexity for developers and really just entire teams who don't want to become infrastructure experts just because they build AI applications?
And that's a great question. I got to say, the inference router that we've just announced at DO Deploy is probably the best example I could come up with for exactly that to respond to that question. It is specifically designed to abstract away the complexity of AI so that AI operators who just want to call an API to have an inference model run against their data set can just do so. And so the development can run extremely fast as a result. And what we're finding is that developers who use the inference router are, orders of magnitude faster, not just like 20 or 40% faster, but they're able to prototype that much faster because they can prototype with their data set on a high end model very quickly and spend maybe $100, $200, $300 to develop a working retailable product, and then tune that down and actually offer it at different price points for different customers. So they have not just a super high performance offering, but a low performance offering, a lower SLA at a lower price point. So that offers them a breadth of capability to offer to their end user with their AI products in minutes, where this used to be something you had to have an entire team of sysadmins, an entire team of data scientists building that back end and creating all that availability of that resource to you so that you could have those options to offer those customers. We offer this built in. We have your day one operation with DO can leverage these resources dynamically and can start delivering that value to your customer immediately. And so we've had, since DO deploy, we had this huge influx of customer interest around the inference router and around the capabilities that DO has as an inferencing platform. And it's been just really well received in general by the industry. It's actually industry first, and we had this massively cool product developed.
Amazing.
Awesome.
Yeah, when you kind of zoom out across the full stack, being industry first, right, and you're looking at compute, storage, and data movement, what are the most important optimizations that organizations are still overlooking, in your opinion?
My big keyword is density. Admiral Grace Hopper used to wear a necklace, which was a little coil of copper that was 11.8 inches long, about that long, right? And that was her nanosecond. She said, for every one of these you have in a system, you introduce 1 nanosecond of delay into that system. Now, when you think about the miles of copper that are in an AI cluster, like 128 node, 1024 GPU AI cluster, right? Say a B300, we're talking miles of copper. And so that's milliseconds of delay. When we talk about the fiber interconnecting those systems, we're talking about miles of fiber, which is, again, milliseconds of delay. Those stack up into delays that directly impact how quickly that AI cluster can reduce data, can transform data from its input set to a derivative output, right? We address that issue in a lot of ways. First off, we build the densest possible cluster. So DigitalOcean has just adopted liquid cooling. We're rolling out liquid cooling in 2 new facilities where we're building extremely high density B300 and MI355X liquid cooled solutions that have the densest possible cluster configuration. So as few, basically inches between racks, as few nanoseconds as possible between the GPU fabric and the servers that are in it. And the big aspect of that matters the most is that we have all of the local storage on each one of those servers. So when that data set is moved into that environment, it has the minimum possible delay from any one server to any other server in that cluster. It literally microseconds of delay from host to host instead of milliseconds. And that shows up directly in the compute time it takes to return results. It reduces the amount of time that the GPUs are working to do that data set reduction, and therefore brings the customer costs down overall, while also just improving time to first token, time to results, just overall performance of the AI solution. So having those Solidigm SSDs and NVMe in the cluster, proximate to the hardware, proximate to the GPUs, as few nanoseconds away, so that AI cluster can be as performant as possible, has been one of the key design aspects that we've taken on that other companies have not, and is one of the key differentiators in our product as a result. So I think Admiral Hopper would look at us and go, hey, you're doing right. Make those things as small as possible. Looking at next gen solutions like AMD Helios, which is a double wide rack that'll be twice as dense as current solutions, for instance. That's more of the same. They're packing more in the same footprint as densely as possible. And again, storage shows up in that same environment. It'll be in that same rack, in that same cluster for the same reason.
Awesome.
That's incredible. I've never heard that reference to Admiral Hopper, and that was a really cool way to think about it. And I love where you're going with density. But I think a question to both of you is we know that the market is not going to actually slow down. We know that, new models like agentic are coming on that challenge data infrastructure even more. So how do you see the interplay between data infrastructure and AI evolving over the next few years? And what shifts do organizations who are running AI today or building out AI clusters need to think about in terms of preparing for that?
Great question. It's the relationship is actually already shifting, and it's just going to continue to accelerate. AI is defining infrastructure requirements. It's not the other way around, and so it's really more about what does the model need, and how do we build backwards. Like Dan was saying, organizations, customers of ours, they need to focus on where the data actually lives and how it would be as close as possible. If organizations aren't thinking about that, the data placement, server proximity, they're going to be constrained in ways they don't anticipate or even know about, and it's going to be too expensive to backtrack that and fix. The edge is actually entering into the conversation a lot now. Inference is moving closer and closer to where the data is generated, so it puts a lot of new pressure on storage and the infrastructure to deliver the same performance expectations, but with a lower power, smaller footprint. And like Dan was saying, with liquid cooled, we have our liquid cooled solution that we offer, which has been adopted by lots of the leading like DO companies out there, and a key player to help them reach their goals for power constraints and still getting the performance they need. This whole TCO discipline, is actually going to separate the leaders from the laggards, because as AI is scaling, the economics is just getting wicked fast. And you have to look at infrastructure as a strategic cost, not just a utility bill or something you focus on later, because that's going to be the big differentiator between who's succeeding and who's just falling behind. So the ones who are really getting this right are the ones that are kind of not just going, well, how do we run AI? What do we need to do? But it's like, well, how do we make this sustainable, scalable for future growth so we can continue to be successful? And that's what you got to look at now. As Dan was saying, there's tons of companies coming out there, but not everybody's doing everything right. They're just saying, hey, we're a GPU farm, we can help you with this, but they're not focusing on the storage or the overall performance or where your data is or how your data is performing or the impacts on the GPU. And if you're not really looking at the bigger picture, you're going to fall behind. You're not going to offer a good solution.
I'd add to that also, one of the things we're looking at is vertical integration. As a cloud operator, like Ty said, infrastructure becomes more critical to our business every day. So moving away from being a hosted service provider into moving into owning our own data centers and to building our own data centers is something that DigitalOcean is doing as a cloud service provider to meet that demand and try to be more ready for that. For customers of ours, we're looking to move more quickly in the AI space. One of the ways I'd say they can look at improving their velocity is by improving their storage clusters in general. A lot of our customers are coming in with legacy hardware saying, oh, our clusters are 10, 12, 15 years old. We don't have the infrastructure to upgrade them right now. We don't know what to do to fix that. Well, you can work with us to talk about how we can refresh your storage infrastructure, creating mirrors of your infrastructure in our data centers and our infrastructure instead. And also how we can work with you to how you can work with your OEM vendors and so on to refresh your storage on your on-site on-premise to try to also improve experience there. But that's the one thing that I see people aren't really investing in right now is that improvement in storage infrastructure. There's a lot of focus on, okay, I got to go buy GPUs. I got to go buy some high-speed networking for the GPUs. But then nobody's talking about where the data is coming from and where it's being written back out to. So that's one of the things I'd say folks can focus on. Look at how you can improve your storage cluster performance. Look at what new solutions are out there. Look at companies like Vast, for instance, that are providing storage clusters as a service that use Solidigm hardware to deliver that capability. Ways to sidestep those limitations of your older hardware, right? And then the other is to basically reduce the input of the volume of the input data set. That's something that a lot of folks don't really pay much attention to when they're looking at the AI solutions they're designing. They're like, oh, I want everything in my data set. I want to take the model that's trained with all of Wikipedia and all of the internet, all of everything. if you start looking at reducing what you're actually trying to, like, your target in the AI space, you don't necessarily need a large language model for a lot of the work you're doing. You need a reduced model that has a very limited set of understandings that can take in A, B, and C and output X, Y, and Z. And so a lot of companies are coming at this with this massive Swiss Army knife that can do all of these things, and it's costing them massive expense because it's running on this massively performant hardware and so on to be able to do all of that. And it's the joke is like software SREs using Claude to do awk and sed transformation of data just to use tokens, so it shows their leadership that they're doing AI work, right? It's I guess it's using the system the wrong way is the best way I can put it. So trying to get away from that, trying to optimize your input data set and your model for exactly the thing you're trying to achieve is the best way you can achieve efficiency and velocity, because you're taking out all that overhead of it having to do all the large language model stuff and having all of that understanding and capability that you're just not using, right? So a lot of customers don't even think about that. They go, oh, I just want to use Claude for everything, or I want to go Open Claw or Nano Claw or Nemo Claw or whatever, the new hot stuff is. And they can't figure out where they need a, 32 GPU cluster to run that when all they're doing is basic, SCADA data processing or something like that, right? They're using this massive overkill tool for this really limited job. So looking at that input data set, looking at the model that you're using and aiming for a model more suited for what you're trying to accomplish is probably the best way to optimize to reduce your costs and improve your velocity, right?
Amazing. I think our audience is going to be very curious and want to learn more. But for both of you guys, where can teams go when they're early in the journey to learn more about what you both bring to the table?
I would say the DigitalOcean website is a wealth of knowledge around AI solutions for training, for inference, and for general computing. Anyone who wants to get started with DigitalOcean GPU solutions can visit our website, digitalocean.com. To get started there. If you want to reach out to our sales teams to talk about, larger engagement or something like that, sales at digitalocean.com is the right place to reach out to. Reach out on LinkedIn or on Twitter. Our teams are active there as well. So if you want to reach out through any of those mediums, that'll be effective as well. I know Solidigm also produces a ton of educational materials around storage in general, around the benefits of storage density in particular. And one I saw recently is by a guy named Jordan Ranus of Storage Review. It's understanding the benefits of extreme storage density. And I was reading that document a couple months ago, and it was really resonating with my understandings of everything that we're aiming for in AI and storage and so on. And so I was like, hey, well, I'm going to evangelize a little bit to my peers and so on, sharing it around. It was like, hey, Solidym's doing some great work, evangelizing the reasons we want to build the designs we're targeting. So I'd definitely say hit solidon.com and check out some of the educational materials that are available there. There's a lot of stuff out there that can just improve your perspective and your understandings of why these decisions are important or why investing in one area versus another is important, and what some of the key like KPIs and values you're looking to improve on are. Like, you may not even be aware that latency between GPU systems is one of the key differentiators in how performant a cluster can be. And you may be buying clusters that have very, very latent networks as a result, and that may be why you have poor performance. But getting this understanding of how extreme density can improve your performance, that's definitely a good start. And I think the Solidon webpage is a good place for that. Ty, you have any more to add to that?
I mean, I think I'm out of a job now. You did such a good job there, pitching it. No, yeah, we have tons of information out there. Jeniece and team have been doing a great job. Lots of great posts on, our Instagram page, our website, LinkedIn. There's always good videos, good learnings. Personally, I have some things out on my MySpace page. I've been using Ask Jeeves a lot about Solidigm. You can see some really good things out there if you're interested. Things like that. No, we have tons of we have strong technical teams that we love to bring out to our customers, or to when we go to any kind of conferences. Solution architects, partner ecosystem teams, and they are all working together with us as the sales team to help these customers build out their organizations to really focus on what needs to be done. But for customers or people really rethinking it or trying to get into it from the start, you do really need to focus on where your data actually is, focus on what kind of data, like Dan was saying, what is your true need? What is the data, where your data lives, how you want it to move, what it's going to cost, not just, I need to build this AI giant behemoth of massive GPUs and all these kind of things and that's not going to work and you're going to fail. So it's really, reach out. There's tons of information. Like I said, DO has got some fantastic information, some really great new platforms. And we have lots of information, some good informative videos, talks, all that. And again, everybody's just accessible via LinkedIn, websites, whatever. We're happy to be there to help you out with your questions.
Absolutely.
Well, Dan and Ty, thank you so much. This was so much fun. I learned a lot, and I think it's so interesting, Dan, what DigitalOcean is doing. I've followed the trajectory of your company for a long time, and what you're bringing to market right now just feels so right for the moment. I can't wait to learn more, and we'd love to have you back on the show. Thanks so much.
Thanks, Allyson.
Thank you
Thanks,
very
Jeniece.
much.
Watson, thank you,
Appreciate
Dan.
everybody.
Thanks, Ty.
Cheers, y'all.